This video is on systems of linear equations, solving by elimination and substitution. We're going to focus on solving by substitution for this problem. The steps for solving by substitution are different than solving by elimination. Elimination needed to have x's, then their y's, equals constant. For substitution, you actually want to have it in any format, but if needed, you want to pick one of the equations and you're going to solve for one of the variables. So if it's already in a nice clean format of it's already solved for one of the variables, that's the one you focus on. Because once the variable is solved for, you're going to substitute the expression you just found for that variable in the other equation and simplify using the distributive property and by combining like terms. Now that you have one of the values, we're going to then substitute that value into either equation to solve for the other variable. So the steps are you're going to solve for one of the variables and you're going to plug that expression into the other equation. So for this first example, we already have y equals 3x plus 18. What this means is that since this variable is solved for, we're going to take the entire expression, not the letter y, but the expression. But this expression is equal to that y. So we're going to substitute this expression into the other y because it was y equals. This y and this y will be the same thing. So we can take this 3x plus 18 and substitute it for the other y. So if we rewrite this equation now becomes, this y was 3x plus 18. But this equals negative 2x minus 2 was never touched. We have just substituted the expression into the other equation, but for that same variable, because y was equal, so we took that entire expression and plugged it in for the other y. Y equals, we put it into the other y. Now we have an equation with only one variable. So let's just solve this for one variable. We're going to get all of our x's on the same side, so I'm going to add this 2x to the other side. And we have 5x plus 18 equals negative 2. Now I'm going to subtract the 18 from both sides, and we get 5x is equal to negative 2 minus 18 is negative 20. Now I'm going to divide by that 5 on both sides, and we get x is equal to negative 4. Now that we found that variable, that value of x, we're going to substitute that x value into one of the original equations. And it does not matter which. It's whichever one is easier to solve for, so it doesn't matter. I'll just take my top one because I want y equals. So we're going to substitute it. I'll take my y equals 3x plus 18. I'm going to substitute my x value. So I'm going to keep my y equals 3 parentheses. I'll plug in the negative 4 for my x plus 18. So now to simplify, 3 times negative 4 is, so we have y equals negative 12 plus 18. Y is equal to 18 minus 12 is 6. So the x value is negative 4 and the y is 6. So our solution is negative 4, 6. Because this is our x, this is our y. So for substitution, you're going to take an entire expression and plug it into the other value. It's the same thing we did with the x equals -4. Since x is -4, we replace the x with that. The only difference is that this has letters and numbers in it, so people get confused with that. But please don't get confused because it's the exact same information. It's the exact same concept if we're plugging in just one value. We're just plugging in an entire expression for it. We do the same thing. If I look at a couple of other examples, so this one, I want to see if any of the equations are already solved for a variable. X on this first equation is already solved for. So I actually want to focus on this x since I don't have to do as much math. What I'm going to do is take this entire expression of -7y minus 16, because that's the x. This is equal to x. I'm going to plug it in for the other x, because this is equal to x. So what this becomes, since I circled the information on the top, I have to focus on the bottom. Focus only on the bottom. I have -5 times, since I'm plugging something in for x, I put in that -7y minus 16, and then I continue on. Minus 4y equals 18. Now I'm going to use the distributive property to simplify this and to solve. So we end up with -5 times -7y is positive 35y. -5 times -16 is a positive 80. Then we have just minus 4y equals 18. Now I'm just going to combine my like terms. 35y and -4y is a 31y plus 80 equals 18. Now I can solve. I'm going to subtract the 80. We have 31y equals 18 minus 80 is -62. Divide by 31, we get y equals -2. Now that we have y equals -2, I can now substitute this value back into one of the original equations. Since I want to find, I have y, I need to find x. If I look at my first one, x is by itself already. So I'm going to plug it into that first one. So I'm going to rewrite x equals -7y minus 16. I'm going to substitute this in because x is already by itself. X equals -7 times, my y is -2. I'm going to keep going with -16. So we have x equals -7 times -2 is a positive 14 minus 16. So x is equal to 14 minus 16 is -2. The x value is -2 and the y value is -2. So our solution is x of -2, comma, y of -2. This was the x, this was the y. This problem, had the x already solved for it, so it was a little bit easier because one less step of math. We took that entire expression that was equal to x and plugged it into the other x. Because this expression is equal to x, we put it into the other x. On this last problem right here, we have -6x minus 8y equals -18, and 3x plus y equals 0. What we want to do here is find one of the equations where we can solve for one of the variables easily. We have numbers on x, y, and x, but this y has a 1 attached to it. So if we solve for this one, all we have to do is just get this 3x to the other side. Let's do that. So we're going to take this second equation and solve for y. So we're going to have y equals just 0 minus 3x is -3x. So if I were to rewrite these, this would be -6x minus 8y equals -18, and y equals -3x. Since we have one of the variables by itself, we're going to take this expression. This expression is equal to y, so we'll put it into the other y. And we'll rewrite this. So the top equation is the one that I have to focus on now. We have negative 6x minus 8 times the negative 3x, because that is what we have substituted into it, equals negative 18. Now we can use the distributive property and solve for this variable with x. We'll have negative 6x, and then negative 8 times negative 3x is positive 24x is equal to negative 18. Negative 6x and 24x combined, which is give us 18x, equals negative 18. When we solve for this, we'll have x is equal to negative 1. Now that we have x is equal to negative 1, we can substitute that value into one of the original equations. It does not matter which equation you want to put it into. You can focus on which one would be easier to find, and so if I look at the top one, I would have multiple letters. But the bottom one, I would plug in the negative 1, and then I could just solve for y easily. So I will actually, on this video, plug it into my second equation of 3x plus y equals 0. 3x plus y equals 0. I'll do 3 times, my x is negative 1, plus y equals 0. So 3 times negative 1 is negative 3, plus y equals 0. So in order to solve for y, I will just add 3 to both sides. I'll have y is equal to a positive 3. Now that I have both x and y, we can write our solution as x is negative 1 and y is positive 3. So in this case, we had to take one of our equations and solve for the variable. Once we solved for that variable, I just rewrote it so I could see it nice and clean. I substituted that expression that was equal to y into the other y and rewrote it. Then I only have one variable and I can solve for that variable. Once we have that value, we can substitute that value back into one of the original problems and solve for the other variable. We can always check our solution by plugging in the x and the y into the original. So this would become negative 6 times negative 1, and then negative 8 times positive 3. So that would become a positive 6 and a negative 24. 6 minus 24 is negative 18. We could also do 3 times a negative 1 plus a positive 3. So negative 3 plus 3 is 0. That tells us that our solution is correct, because we can always plug the x in for the x and the y in for the y to see if it gives us that answer. And in this case, it does.